and you boot these servers up in Swarm, would you expect the cluster to work? How many of y'all would expect that? This person would expect that. 4 out of 12.
We call that the Vulkan mind meld.
What's that?
Vulkan mind meld, where you take the data from one system and you move it to another system and it comes up and it's there, yeah?
It works.
It does, yeah.
So just on that, is that just a natural byproduct of your architecture, or did you do that to meet customer demands and market requirements?
So that is a natural byproduct of the architecture. In fact, we've only had one customer who ever actually had to do something like that, and they were actually quite surprised when we said, sure, do it. But what it does is it tells you a couple of important things about Core Swarm. One is that the nodes are, except for the data volumes they're serving, stateless. I mean, all they know is I have these volumes and here's the hardware I'm running on and here's the rest of the cluster and what it looks like. And so it adapts to whatever hardware is out there and what volumes are out there. And the way it does that is in part by keeping some notion for each volume of each volume's willingness to take on more data or to serve the data it has. And this is what we call the data market. So that's one thing it tells you. The other thing it tells you, and really the reason we built this in was for manageability. Because what this allows is when you want to stand up another server with empty volumes, or when you have some server whose two out of its 4 volumes have failed, and so you want to take those 2 and put them somewhere else and retire that piece of hardware, or when you want to do whatever you want with regard to hardware management, that you can pretty much do it. In addition to the data market, another part of the core product that allows that is something we call fast volume recovery. When a volume is lost, all of the other nodes in the cluster recognize that loss and very quickly create the necessary replicas or erasure coded segments to bring the objects that were on the lost volume up to par with regard to redundancy. And that pretty much gives you a 5-minute notion of what Core Swarm is doing. What it's presenting, of course, is a simple REST API to the objects themselves. How am I doing on time?
4.5 minutes.
Okay.
Keep going.
I'll add one other thing to that. Part of the way that's done is all of the nodes together cooperatively have a RAM index that maps each object's ID, UUID or name, to where the object resides on each volume. And so we can actually find all of the objects, all of the replicas of an object, without doing any disk access whatsoever. And that, it's not obvious that that's a necessary part of that architecture, but it really is, because without that you end up doing so much disk work to sort of coordinate where things are and make sure they have adequate replicas that it would just be useless. You really need that ability to say for any object, how many replicas do you now have? and get an answer without having to go through a directory or through a database or really through anything except RAM.
So can I, quick question there.
Yes.
What requirement does that put you on the amount of RAM that you need to have? Does that become a bottleneck to your design?
So we did design a very compact distributed hash table for that. We consume 34 bytes per UUID. And typically, a mutable object will have both a UUID and something that looks like a UUID to represent the name. So not very much at
Not
all.
much.
Can you speak to the importance of archive? That too.
Good point. One thing that allows is a mode that we call dark hive. What we typically do in most active clusters is try to balance content across the volumes, since all the content is potentially actively served and updated. But we do have a mode for dark storage, or what some people call cold storage. And what that does is that says we try to fill volumes up as quickly as possible and then spin them down. And one of the reasons we're able to do that is because we still know what objects are on the volume in RAM. And so if you do need to go to your cold storage and retrieve an object, we can spin up that volume. It's not going to be as quick as getting to the object if it were already spun up, but we at least can manage the cluster while volumes spin down.
Sorry. If you access that data, excuse me, if you access that data, does it bring it back up in the warm storage? So
Yes.
it's assuming that it's going to be used again for whatever that cutoff time is or whatever.
Russell, I'd also like to point out that the data market allows some important things, such that if you've got multiple volumes with content and one of them is spun down and the other is spun up, then through the market mechanism, you can assert a preference for access going to the one that's already spun up.
Okay.
And so the market takes not only that state, but it also takes into account actually how busy the volume is. And of course, one part of what determines how busy a volume is how fast a volume is. And so faster volumes get preference over slower volumes.
So can you set a preference, like if the data, I mean, whatever it might be, that if I do access it, don't leave it hot. Once it's accessed, spin it back down? Is that an option as well?
We currently don't have something.
Well,
I mean, I don't even know if it's
there is a tendency the sleep after there is a preference that you can set that is kind of a weak pull towards attempting to get nodes to spin down, which means that they won't turn away requests, but you can set a preference to try to let them go to sleep, where they will adjust their bids in a way that allow other parts of the system to take the request such that they can spin down.
Okay.
Because if you didn't do that, then the system, even just a little bit of activity would keep the entire cluster awake.
Yeah.
And so you can direct activity to go away from nodes that have, the analogy that they've gotten too tired. They've been awake too long, so they have this tendency to want to go to sleep.
Do you support Erasure Coding? Because you have this concept of the volume. Of course, it works if you have copies. But with Erasure Coding, you have multiple segments, so it's not that easy.
That is correct. And so Russell actually started with the idea of replicas as a good first way to explain it, but the concept actually extends out to multiple segments that occur in an erasure-coded object. So yes, erasure coding works with this as well.
But you need many more nodes, so just for very, very, very large installations.
You can't have, if you try to write with an erasure coding that's greater than the number of nodes you have, the write will be rejected. And that's just sort of a hardware constraint. For that matter, the same thing will happen with replicas. If you have, we don't formally support clusters with fewer than 3 nodes, but if you had a 3-node cluster and you tried to write an object with 4 reps, you'd get back some 400 error response that says, I just don't have the ability to do that.
So there's a couple of questions there. So on the first one, you said that this is a mode that you can turn on for turning on sort of dark.
Which is a mode?
The mode to turn it into dark cold storage.
Yes, that's a mode.
Right. So why is that mode not on all the time?
It's not on all the time because the use model there is that you're really going to have most of your volumes down most of the time. What it does is if you start a cluster with empty volumes, it actually has a preference to put data on the volumes that are close to full, get them full, and shut them down to preserve amps.
Okay.
And that's not how you typically want to run a cluster that is actively serving data.
Okay.
One of our customers, for example, is Match.com, and their data is always being accessed, and they would not want it archived, and most customers don't want that, but there are customers who want that. Now, what's interesting, let me put out one other use case. One feature we have that doesn't get much talked about is something we call feeds. And what a feed does is, and a feed is actually represented on the data volumes, and what it does is it keeps track of data that is supposed to be pushed to some outside destination. And there's actually two important outside destinations that we push data to. One is another cluster. And so you can have a disaster recovery cluster that takes data from 3 or 4 or 5 clusters that are actively serving it. Another important destination is the NoSQL search engine we embed for metadata search. And so what feeds do is they make sure that every object is not necessarily its data, but it's somehow pushed. It could be the metadata, it could be the data itself to some destination. And the use of a DR cluster is kind of interesting because that's where you might have several active clusters that are actively serving data, but then you have one cluster that is sort of your geographically remote disaster recovery, and that you can have as a archive because you're not actively serving data from it.
Okay, and they can be connected together.
Yeah,
Connected to each other. Yeah, okay. And the other thing that you mentioned there about being able to set, I think, the Erasure Coding parameters
Yes.
in the same way as replicas. Is that so? That's per object. I can say I want this much.
You can do
Erasure.
that per object.
Yeah.
Can I talk about policies? Sure. So we're moving forward. What we're sort of pushing is the notion that those kinds of things should be set at the domain and bucket level.
Yeah.
Since that's just a more convenient unit for setting that than per object. And when you set a policy for erasure coding, what you typically do is you say, well, I want objects that are larger than a megabyte or 10 megabytes to be erasure coded in order to say footprint, but smaller objects I want to be replicated because I don't want the overhead of doing that.
Yeah. And I mean, one of the advantages of erasure coding is you can dial in how protected they
Yes.
can be, much more fine-grained than other things.
Yes.
So being able to do that as I can see that from a policy perspective if it's a default for a certain location, but are you still able to override that on, look, generally, here is my bucket
Yes.
of storage, I'll set it up, but it's like, for this particular object, I want this to be more protected.
You can
or something
override it.
else.
And in fact, you can not only override it per object, you can actually give the object a sequence that it goes through. You can say, I want this object to have 3 reps for the first 30 days because I expect it to be needed for the first 30 days. And after that, I want it to be erasure coded 5.3 to save footprint but still have good durability.
Yep.
Can we just
That's pretty cool.
for the sake of the video, I guess, and the people who are listening, you've used the term reps quite a lot. It probably would be a good idea to qualify that you're talking about replicas, I guess, and
Yes,
actual whole copies of that data spread across nodes.
yes.
Yeah.
Is that also then across data centers? Is there a high availability component?
So one thing we have built in to again, Core Swarm is the notion of subclusters. And what subclusters are is they're just a way of coloring your nodes to say, make sure when I have reps or erasure coded segments that they're maximally distributed across the subcluster boundaries I define. And so one thing that lets you do is have a cluster where some nodes are in one building and other nodes are in another building, and know that the data is going to be dispersed across the two, so that if you have some sort of physical catastrophe, a fire or a flood, that takes out one, you still have the other.
So Russell, do you, and I'm not sure I heard what the question was, but do you do geo-dispersed erasure coding kinds of capabilities?
In that sense, yes.
But it's not replicas, it's actually erasure coding.
Yes.
So you could have a cluster over here that has, 1/5 of the data and some portion of the parity in other clusters. And in that kind of environment, do you have to reconstruct the whole stripe, or can you deal with like partial stripes to recover the data and things of that nature?
If you have like 10-5, then we would need
10-5 is, yeah,
then
so 10 data by parity kind of thing.
Then we need 10 segments to reconstruct one that's missing. Now, being an engineer, I'm like all engineers, I sort of have to qualify my answer. The current way we do subclusters requires connectivity. It doesn't work across the WAN.
Okay.
I have another question about the life points. You guys mentioned that has to do with like changing the replication reps. Does that also imply that it might take me a little bit longer to open something I'm trying to get at? Like if I move it to a different life point, could you maybe expand on what that means a little bit?
So retrieval access is sort of interesting because it depends in part on how you're retrieving an object. If you're reading an entire object, there's some, you actually can get benefit from erasure coding because you have more volumes that are more quickly marshaling the data. On the other hand, if it's a smallish object, the fastest thing is just to go to where it is and get it as an entire rep.
Russell, do you think
there
that
are
it's
some differences?
I think the point you're getting at is there a transition period in time in which the object is transitioning state and thus less available for reading? And the answer to that is no.
Right.
The
okay.
objects are actually converted while leaving the first in place, and it's only after it's been converted that the old one is removed. And so, and this is happening around the cluster. It's not a point in time at which every single, if you have 4 replicas of an object, all 4 are not instantaneously undergoing this transition either.
Thank you, Eric, because I didn't get that question. And in fact, when you update a mutable object, if someone's reading the current version, and this is important for large objects, if someone's reading the current version of a mutable object, when someone else comes along and writes a new version, the clients that are reading the now one back version continue reading just fine. There's no, they don't lose out just because that version got updated while they were doing their read.
Okay.